This is Mr. V. Welcome to this video series on linear programming. Today's video is going to be on finding the objective function. It is important to note that before we've worked with lots of different equations or inequalities. The objective function is exactly the same, except for one important distinction. The objective function is the thing we're trying to find. It gives us the objective of the question. It is the one value that we either want to maximize or minimize. So often you'll have lots of different inequalities and equations going on, but you want to find out which one gives you your objective. So what's the thing you want to maximize or minimize? So here we've got a simple example. Janice and Paul are planning to build some animal hutches for sale. They have two basic designs: small animal hutches and big animal hutches. Small hutches cost $20 each for materials, and big hutches cost $35 each for materials. So as always, we're going to start with our variables and parameters. Now in this question, we've got a cost, so one of our variables will be cost. We can also change the number of small hutches we build and the number of big hutches we build. So I'll write small hutch and big hutch to represent how many of each we build. Now the parameters are the costs to build each type of hutch. So for small hutch it costs $20 each, and for big hutch it costs $35 each. That's part A. Next we want to write the equation for cost, and we're told that that is the objective. So that is the thing we want to maximize or minimize. So how do we calculate cost? Well, cost is dependent on the number of small hutches and big hutches. It's going to cost $20 times the number of small hutches plus $35 for the number times the number of big hutches. And that's it. That's our equation. Now, do we want to maximize cost or minimize it? Do we want to make it larger, maximize, or smaller, minimize? Well, it's a cost. We want to keep costs down, so we want to minimize the cost. And that's it. I'll quickly show you another one. Dat and Fan sell pineapples, watermelons, and mangoes by the side of the road. They make a profit of $1.50 on each watermelon, 90 cents on each pineapple, and $1.10 on each mango. Same process. Variables and parameters. We're told that these each make a profit, so these money values are a profit. And we can change the number of pineapples, the number of watermelons, and the number of mangoes. Now in this particular problem, it doesn't matter how many variables we have. It's only until we need to graph them that it becomes an issue. And we don't have a problem at the moment. The parameters we've got associated with these variables are $1.50 per $1.50 per watermelon, 90 cents per pineapple and $1.10 per mango. Now the objective function for profit is very simply going to be 0.90 times the number of pineapples, let's make it P, plus 1.5 times the number of watermelons, plus 1.10 times the number of mangoes. Let's keep it as M. And this is profit, so we want to maximize the profit. And that is how you determine the objective function of a question.